I saw this example on trigonometric integrals, and I feel it will be great I share it with you, my audience. It will help us see trigonometric identities and also how to treat curves in trigonometry. You can pause this video and try it on your own before seeing my solution. That said, let's get into class. Now, our example says we should find the integral between 0 and 2 pi of the root of 1 minus cos 2x. Now, if you look at this closely, you see that this is cos 2x, and from our knowledge on trigonometric identities, you remember that cos A plus B is the same thing as cos A cos B minus sine A sine B. So that if A is equals to B and B is equals to X, that is both of them is equals to X, I'll have cos 2x, which will be the same thing as cos X times cos X, that's cos squared X, minus sine X, that's sine squared X. Remember that cos squared X is the same thing as 1 minus sine squared X. So that cos 2x will be the same thing as 1 minus 2 sine squared x. Invariably, 1 minus cos 2x will be the same thing as 2 sine squared x. What I've just simply done is I have just made 1 minus cos 2x the subject of formula, or rather I have defined for 1 minus cos 2x so that I can now substitute in this equation, so that my equation now looks like 2 between 2 pi and 0, the root of 1 minus cos 2x will be the same thing as 2 pi and 0, 2 sine squared x, and here I have square root with respect to dx. Now let me just rewrite it properly. Here my equation is, this is 2 pi, that's 0, that is the whole of this is equals to 2, here is sine squared x dx. But remember that there's a square root here. We have it to square root. So I can now rewrite this to be the same thing as square root of 2 into 2 pi, and here is a root of sine squared x with respect to dx. Now, if you look at this carefully, you have the root of sine squared x. We can really break that down. This should be the root of 2 pi to 0. Here will be sine x with respect to dx. But if you do this, I'll tell you that you are wrong. Because if you do this, easily you tell me that you want to integrate sine squared sine x directly, which would lead you to a wrong answer. So that taking the absolute value, we'll be saying that the root of 2 integral of 2 pi of 0 square root of sine squared x with respect to the x will be the same thing as the root of 2 pi of 0, taking the absolute value of sine x with respect to the x. Now, I'm taking the absolute value of sine x, and I'm moving between the 0 and 2 pi x. First and foremost, I want you to see the curve and see what the curve looks like. Now, the curve of sine x will originate from 0 and move this way, where here is my 0, here is my 2 pi, sorry, here is my pi, not 2 pi, sorry. Here is my pi, and here is my 2 pi. Here's my y-axis, here's my x-axis. At this point, x is equal to 0. At this point, x is equal to pi. Then, between x is equal to pi and x is equal to 2 pi, the graph comes in negative. Now, but since we are looking at the absolute value, we will not be looking at it in negative. Rather, we'll be seeing it this way because we're looking at the absolute value from 0 to pi to come this way, and from pi again to 2 pi, the graph will come in the positive. So that I'll have it at 0, at pi, and at 2 pi. That said, I can now divide my equation, or I can divide my integral into two parts. That is, I can have this to now look like this. Here I'll have root 2 into the integral of between pi and 0, which is the first quarter, between pi and 0. Remember, this is positive. Here it is what? Positive. So this is sine x with respect to the x. Then plus the integral. Here is my 2 pi and pi, but here is negative. So that is the integral of minus sine x with respect to the x. That's the negative part. Now, so that this now will now look like equals the integral of 2. Here is integral of sine x is the same thing as minus cos x. That will be minus cos x is moving between pi and 0 plus a. Remember, I don't want to miss my root 2 that's outside here. This will now be between minus sine x. The integral of sine x itself is minus cos x. So the integral of minus sine x will be minus cos x, which is positive cos x. And it is moving between 2 pi and pi. I'll close the bracket here. That's equals to root 2. I have root 2 outside. So that I'll have minus cos pi minus cos 0. Let me close it there. Then plus cos 2 pi minus cos pi. Cos 2 pi minus cos pi. Bracket close. So that here I have root 2 into minus cos pi is the same thing as minus 1 minus cos 0 is 1. That's minus 1 again. This closes. Plus here is cos 2 pi. Cos 2 pi is the same thing as 1 minus cos pi as minus 1 again. This closes. So that I have this to be equals to root 2 into minus this is minus 1, that's minus 2, minus outside again, that becomes plus 2, plus, there's a wider bracket here, yes, plus 1 minus 1 here, 1 minus minus 1, that's 2, because the minus minus becomes plus, that's 2. So here is just plus 2 plus 2, that's equals to root 2 into 4, which is the same thing as 4 root 2. With this, I hope you understand how I perform this trigonometric integration. Thank you for staying with us and see you in our next class.